So this is the idea. By the way, with this framework, the idea is that you will understand how different network devices exchange data and connect with each other. So what I did at start is, basically, I used to play with some specific devices, like, for example, cable modems. There are a lot of there are no simulators, neither too much information about this kind of stuff. So while trying to do some work, I realized I was needing a simulator, and that's why I started. What do we see here? Well, if my timing about the presentation is good, I will try to show you the idea, some basic architecture about this project, and we will play with this framework. We will create our own devices, virtual devices. We will create our own protocols. We plug in, we will see it. So, after talking about ISP war, well, I'm not talking about ISP because they are important in this talk, not really. The truth is that I would like to show you why I started this. What were my needs, and why I decided to make this framework. So, a few months ago, I was playing with an HTTP server, and what I was needed is to measure how a change on the HTTP server affects on the network traffic of different devices. So what I did is I say, okay, it's not viable to create to have a lab with hundreds of thousands of cable modems. So what I did, I say, let's start thinking about cable modem. So I say, what do we do? It's a simulator for a cable modem simulator. That's what I thought at the very beginning. But as I said at the very beginning, the idea was to make it in a realistic way. So I started scratching a little bit, and I found that there are other network devices that does packet manipulations, and if I would like to make it as real as possible, I have to include them. So this is a very basic graphic about how a cable modem goes through the internet and on an ISP, and also how a PC through a cable modem goes to the internet. I start with the cable modem, but suddenly I found there's another box which is the CMTS, which is there. We won't talk much about CMTS. It doesn't matter here. The point is that this box, which is really expensive, we're talking about thousands of dollars. Basically, what it does is just work as a router. It gets packets from the cable modems and send it to the internet or the HTTP server or whatever. So this box, which is really expensive, I need to simulate it also. But this is not at all. I realized that in every ISP, we have not just one cable modem. And if I would like to understand how the traffic was affected by a change on the HTTP server, I would need to work with hundreds of even thousands of cable modems. But this is not all, because as we know, at least every cable modem has at least one device, which is a PC, which is connected to it. And if we have thousands of cable modems, we have also thousands of PCs. So, kind of, I was fucked. So here's the situation I was faced a few months ago. So it sounds I have a trouble. Well, the problem to solve. I have no chance for a lab, not a real lab, because I can ask to anybody to buy me a CMTS of $30,000. And I was needing critical mass, and because testing one change with one cable modem or one PC, whatever, it's nothing. We need hundreds of thousands of devices. So it's impossible to have any lab. Let's say we have a CMTS, which is very expensive. We will also need hundreds of cable modems and hundreds of PC connected to cable modems, which it's impossible. And lastly, there were no open source simulator for that. Even though there was no simulators so flexible and so flexible as I was needed. So everything what I found is it was closed source, was not flexible as I was needed. I can't do anything with that. So this is why I decided to start my own framework. And this is the first thing about the Python that I would like to share with you. It's when I decided to start this framework, I thought that it should be in C++. I know I have background in C++, I have background in Python, and I thought that C++ would be better. Why? Because we are talking about network traffic manipulation. It seems like it should be fast, and C++ it's faster than Python. So I started in C++ also. But what happens? I found some libs, and I started crafting the framework in C++. But when I was coding for about 2 months, I realized it wasn't going really fast as I would like to. Just because of the language, basically. So I stopped, and I decided to see what if I do it in Python. And there I found a tool which was really helpful, and I encourage you, if anybody here is working with network devices, with networking, sorry, you should try Scapy. I don't know if anybody here knows about Scapy, but it's a network library made in Python, and it helps me a lot. So what I realized after developing this in Python, I found that I did it 2 or even 3 times faster than in C++. Not talking about performance. We're talking about the time developing. This is great. This is like a proof of concept that we can do this kind of stuff even in Python, and it works. So now we know by now what my needs were and the situation I faced. I made the decision to make it entirely in Python. So now I was needed to make the requirements for the simulator, for this framework. So a few of them. It should run on a notebook. Don't want any expensive requirements. I was tired of that. So it should run almost everywhere. Even on virtual machines, which also I will show you in a few minutes how does it work on virtual machines. It should simulate real network traffic. It's not possible for this simulator, for this purpose, was not possible that looking at network traffic, you can tell if this was originated by a virtual device or a real device. So, the network should be as real as possible. No tricks, in any packet, on any flow, as real as possible. Scalability. Well, as I said, we were trying to play with hundreds of thousands of devices, so we should be able to do that. Client server and modular architecture. Well, everything will be run on the process which is called simulator. Everything. So the idea was that if I implement a client-server architecture, the client can connect to the simulator and send some commands like retrieve information about the simulation status, create devices, add devices, send commands to any device, exit the simulation, stop the simulation, whatever. That's why I start with the client-server architecture. And model architecture, because we're talking about network devices and protocols. So it should be easy to create new protocols and add new protocols to any virtual device. So that's where my needs. A little bit about the architecture. I don't want to go really deep about this, but just a few comments. This is a really crappy graph, but it's fine. We have as you see, we have a host, which is where we run our simulator. We have a few, the layer with the C, it's called the command listener. And what it does is just receives commands from the clients, and it put it on the appropriate place. I mean, if it's a command for the simulator, it will drop the command to the engine. If it's a command for let's say for a device, it will drop it in the queue, which is with an N, which is a network packet queue. So we have a dispatcher which take off the message from QN, which is a network packet. And what I didn't say is that this queue is has the whole packets that are running on the simulator. So every packet goes through the NQ. We have some stats module, config module, never mind. The important here is the virtual network and the dispatcher. Those are the most important boxes in this graphic, and of course the virtual devices also. What's the idea? Well, the virtual device, the virtual network is the network for everything that runs inside the simulator. So, for a virtual device, there's no real network. They send everything for their network, which is called the virtual network. And this virtual network, what it is really is a layer which is it's sniffing everything, and is a router also. So because it has some routing capabilities, it allows us to make that every device on the simulator runs on different networks. Okay, and let's say that our host is running in the network A, and every virtual device can run on network C, D, whatever. Never mind, because the virtual network will route the packets to the net. And the dispatcher, which basically dispatch every message on the network queue to the appropriate virtual device. And as you see, every virtual device has small lines, red lines. Those are protocols. So every virtual device has protocols implemented. They don't need to be the same. I mean, every virtual device implements different protocols. And the dispatcher, it inspects the destination of the network packet, and it sends it to the appropriate device. So this is basically how it works. Okay. Features I have done. Those are the protocols that I already developed, which are DHCP, TFTP, ARPA, CMP, and NTP. Those are closely related to cable modem, all this stuff. But it's really important to understand that this is not a cable modem simulator. It's wider, it's bigger. So I start implementing these protocols because I was needed. but right now I'm implementing DNS. For example, just for fun, I'm working with some HTTP protocol also. So, link layers, Ethernet, that's it. I've made everything, I'm spoofing everything because, as I said, the virtual network is the router for every virtual device, so everything is spoof. Every device has an IP, every device has a MAC address. So, because everything is running on a host, which has different MAC address and different IP, what I need is to spoof everything. Event-driven. Well, I think everybody here knows that it's not possible to have thousands of threads. So I decide to implement everything by objects, not threads, and event-driven idea. And now it's a modular. We have the feature that adding new protocols is quite easy because, as I said, every protocol it's you just develop it, just throw it to the simulator, and that's it. It's already to be used for anyone. And an API for a client. This is what I've already done. So to here, I talk about how everything starts. What I will do right now is start playing with everything. So we'll see how this works. We'll see some code, and we'll see. So. Okay. Okay. I have two virtual machines. One, it's running with a DHCP and a TFTP server. And the other one, which is here, it's running the simulator. So we'll take a look at some code and we'll see how it works. Okay. Hold on. Okay, that's better. Let me check something first. Okay. Okay. So I will start running one cable modem. Just the idea is that this cable modem has implemented. This is the cable modem device implementation. As we see, it has implemented ARP, and DHCP. That's it, everything. Okay, so what it says, it's one IP was assigned, and if we see here, we see that there's the IP assigned, which is this one. But let's see this. What I have here is a DHCP dump, and I will try to run the simulation again. Okay, so the important thing here is this one. I have a virtual device which doesn't exist, which has a MAC address which is let me check, is this one. The DHCP server on the other virtual machine, it says it gives me this IP. So it seems it works. Okay. I mean, for the HTTP server, it doesn't recognize it's a virtual device. It just say, okay, you talk DHCP, you talk ARP, so that's it. Here's your IP. Sounds fine. Now, what I would do is, this is for one cable modem, which is fine. What if we're talking about a lot of cable modems? How hard it's to achieve that? Well, it's really basic. I will show you some code first. Sorry. So here's how many devices we would like to create. Let's say 20. Do you remember we talked about the CMTS? Because every cable modem runs on with a CMTS, we need to set up a CMTS. So this is the CMTS, this is the IP address of the CMTS, which is 31. And by the way, if you do right now, when everything stops, the simulator is stopped, if you ping to this device, it doesn't exist, okay? So basically, what I do is this. I tell the simulator, okay, let's create other cable modem, and I ask the simulator to show me the cable modems that are already created, and then I tell the simulator 2 commands. Let's power on the device and give it a DHCP discover. I mean, just let's run the DHCP engine and we'll see what happens. That's it. So we start the simulator and we run the main ECB. Okay. So here it says it sent me 20 AC keys. I mean, 20 KB modems right now are up and running. They have IP assigned, which is fine. It's good. So it just works. We stop everything. And now, what if we would like to add new protocols? I mean, we say this is a real modular. So let's say we would like to add a TFTP. I mean, every cable modem has this this sequence. First of all, it requests for IP, and when it has an IP, it requests for a TFTP file for a configuration file, which is retrieved by a TFTP protocol. So this is what we're gonna do. I will edit the cable modem model, and where it says TFTP, I will add this layer. So now every virtual cable modem will support also TFTP. So we will run just one cable modem to take a look. Okay, as you see, HAL completely received the full2 file, which there's the file size, and we can check it even. Here's the other virtual machine where the TFTP is running. Oh, let's do even better. I will configure the TFTP in the debug mode. Where's here? So we will see everything that's happening is running. Okay. So here we are. the cable modem requested the file via TFTP, and it took something like 3-4 requests because the block size is small, but it's working. So now one thing that's really funny for me, we will add to the cable modem, this layer, okay? So it has a P, it retrieves the file via TFTP, but now this virtual device has also ASMEMP implemented. So what that means? This. What's the IP it has? This virtual device has 65.20. Cool. I mean, we have a virtual device which we are pinging from a real computer, and it's working. It's answering the ISP, the pings. As you see, the times are quite great. I mean, if I do ping, what's the other computer? If I ping, okay. Take a look at the difference, okay? It's huge. I mean, I need to work it out because it's a performance issue, but it's working. So now we have the points that we have virtual devices that they work as a real network devices. For the operating system, there's no difference because they are implementing the protocols as they need. And now let's play with something which is funny also. As we said we can craft our own protocols also. So, okay, what if we are playing with some device which is buggy? Okay, let's say, for example, we have a cable modem which is the DHCP implementation is not working very well. So we can recreate that. We can craft our own protocols also. So I will edit the cable modem. I will use a DHCP buggy, which is basically a DHCP that's not, it's looping forever and ever. And that's it. Just let me show you. I will put everything in debug mode just to show you. And the DHCP is in debug, okay. Okay. Here. Take a look. Now, that's the result of implementing a DHCP protocol which is buggy. So the device never gets the IP address, which, I mean, in some specific situations, it will help us. We can play with protocols, we can craft whatever we want, and we can play with it. So, this is basically, I implement a PC virtual device, but we have not enough time, so I would like to go on with the presentation. Just, but I can show you later if you want it. No. Oh, sorry. Okay. So tools I use: Python, Scapy. I use DHCP and TFTP servers, which the common DHCP and TFTP servers, and I implement Google Protocol buffers, which allows every allows to implement, to create protocols that can be consumed by different technologies like Java, C++, or Python. So you can craft your own clients in any technology you want. I did it in Python. The clients I showed you, they were in Python. With this tool, we can simulate network traffic, the real network traffic, and we can also custom craft our own protocols and our own network traffic. It's useful if you want to craft, implement our own specific device. We can implement. Right now, I'm working on a TR069 device, and also an IP camera. You can recreate expensive scenarios. I mean, there was no chance to have a lab with thousands of cable modems on PCs, but with this, you can do it, and you can measure, and you can see what happened. You can use it also for stress testing, for bug hunting in some specific devices. For example, I can try to craft my own PC which floods in some way any device, and we'll see what happens. I think that's it. Thank you for everything. Any questions?